So the last category of voltage series feedback amplifier, the practical examples, voltage series feedback pair. So it is pair means, I'm going to use two amplifiers. And the two amplifiers are common emitter amplifiers only. So I'm going to connect two common emitter amplifiers in cascade with voltage gain AV1 and AV2 as shown in the figure. Cascade means connected back to back. The input is given to amplifier 1. Output of amplifier 1 is given as input to amplifier 2. Output of amplifier 2 is taken as V out. Okay. And what I am doing here, I am see, just by connecting amplifiers, I don't provide feedback, right? So I have to create a feedback path. So from the output of the second amplifier, I take the output voltage through R2 and I'm going to feed it as to the emitter of the first amplifier. So that is going to be the feedback path. So the output of second stage is returned to the feedback network R1, R2 in opposition to the input signal. See, in voltage series feedback, whatever feedback signal you generate, it has to oppose the input. So through R2, I take the output from amplifier 2 and I mix it with R1 in the amplifier 1, which is going to oppose the source voltage Vs. As the sample signal is taken directly from output node and it is applied in series with external source, it is a perfect example for voltage series topology. So you are going to involve two resistors R2 and R1, which are going to be forming the feedback network, which is going to ensure that the signal is added in opposite sense with the input signal. Okay, so the current coming from the output is I. The current coming from the input of the first amplifier is I dash. So across R1, sum of the two currents I plus I dash is going to flow. So now we are going to draw the basic amplifier circuit without feedback, and then we will be replacing the H parameter equivalent circuit. So to find the input circuit, you have to keep V naught equal to 0. So when V naught equal to 0, you can see that this R2 is grounded. So this V naught is 0 means R2 is connected here. So this point is grounded. So one end of R2 is connected to E, one end of R2 is grounded. One end of R1 is connected to E, one other end of R1 is grounded. So I can say R1 and R2 are parallel. So when at the input side, R1 and R2 will appear parallel. Okay, R1 and R2 will appear parallel because V naught equal to 0. To find the output circuit, you remove the source. Don't apply any input. So this amplifier will not work. Whatever output coming from this amplifier will flow through R2, R1, it will reach the ground. So I can say R1 and R2 are going to be series. So the input side R1 and R2 are parallel. In the output side R1 and R2 are going to be series. And that is justified by applying these conditions. Okay, so for the input circuit, you have to put V naught equal to 0. Observe how the currents are flowing and how the path, the resistances are there. So when you put V naught equal to 0, R1, R2 are going to appear parallel at the input side. When you set II equal to 0, the input current is 0, R1 is going to be in series with R2.